So once you're done with all the diagnostic, you want to interpret your model. You see there are no problem with your diagnostic, with your model, with your experiment, then only then you go to model graph. So you see here, after diagnostic, you have model graph. So you click a model graph there. Click model graph. By default, it give you this one graph, the interaction thing lah. So let's say we want to see all the factor first. Let's say I click here. On the top here, you can see there are what we call, there are a lot of things. Don't get intimidated by that. It's just thing lah. So let's see. Let's look at the all factor first. I click all factor. So it gives you the interaction for all factors. You have seen this before, right? During our first workshop, when I show you how there are experiment on the golf and so on. So you have seen something like this before. So you know, if something like this horizontal, there are no effect lah. There are no effect. Okay. If there is what we call, there are slope, there are some effect. Okay. But look here. If you see here, they give a warning. All have a warning. Let's go to pressure first. Pressure, we know from this graph there are no effect. But also, if you look at the warning, they said factor not in the model. Meaning that even though what we call, even though we create a model, for example, this part, this all factors here, meaning that they show all the factor that we choose at the beginning. What we call the pressure, the temperature, the concentration, and the stir rate. The factor pressure is not in the model, because if you look at the ANOVA here, our ANOVA here, if you see that our actual equation, you can see there are no pressure. Okay, there are no pressure. There are no pressure. So this model graph is help to predict something lah. So here, that's why they said warning factor not in the model. In our case, then it's not a problem, because this, we know this factor is not significant, so we deliberately don't choose that factor during the half normal plot lah. Or the half normal plot, there are no pressure that is jumping off from the line, the normal line. So we don't select that. So that's why there are nothing. So that's okay. But here, if you look here, temperature, concentration, and stir rate, they also have warning. Factor interacted in multiple interaction. What does it mean is that it's not enough for you to look at this one single one single graph alone to make a decision, because your decision might be misleading, because there are interaction between factors. So that's why you cannot use this graph as your decision making ni lah. You need to check the graph against their with their interaction lah. Okay, so let's go for that. Let's go to this interaction factor here. Interaction. So this is temperature versus filtration rate. Okay. So how to see? How to start? Okay, so you see here there are you have two lines. Okay, the red and the black. The red line here is concentration. The black line here is also concentration. It's the same thing, but different level lah. So you can see on the here on the left, or on the left, the red by default in design expert, the red, when you look at the model, the red is always high level. The black is low level. The red is high level. The black is low level. So even though you see there are two lines here, they actually the same factors. The concentration. What make them different is the factor, the level. The red is high. The black is low level. So this temperature. So basically they want to see the interaction between temperature and concentration towards the filtration rate. Okay, so this what this graph all about. You can see here they are like a bar here. Okay, so this bar they call it LSD, least significant difference bar, LSD bar. Okay, so the idea is this: if this bar overlap, okay, if this bar overlap, then no significant. The effect is not significant. If the bar overlap, let's say this bar, if the bar overlap, then the effect not significant. Okay, if the bar not overlap, then the effect is significant. So from here you can already see that this thing, at the low level, at here, at the low temperature, there are significant effect. At the high temperature, there are less effect. Whether you use the high or low is not really much different lah. There are some different. Yeah, they are different. Of course, it's not like they are not significant. They are still significant. No, they are significant because the bar doesn't touch. So meaning that they are significant here lah. They are significant here. So both is significant lah. So you can also check this thing by clicking the thing, and you can get this pairwise comparison. You look in here, you look on the right side here. They try to give you all the detail lah. All detail. If you click here, okay, let's say you click here, you get this thing on the side here. Okay, on the side you can read lah this thing. So you can see they are like what we call they are like a gap and so on. But still, this is significant because they are what we call between for ni lah. I mean that the especially for the black one. The black is what? The black is low value, low concentration of the formaldehyde. So for the red, if you try to take this line, this bar, go next to this, you can see it's overlap. The red and red, the red on the side and the red on the other side. You try to make a line, horizontal line, they will overlap. So that's make this red line is not significant. The red line alone lah is not significant lah in this case. But this one, the black line, if you take this the arrow bar here, the bar here, if you make line, horizontal line there, and then you make horizontal line here, these two lines doesn't meet overlap each other. So we can say here that the low concentration have significant effect. The high concentration have no significant effect. And if you look here, at low level, at high temperature, you get even high filtration rate, which is a good news. Because remember, the main idea of this experiment is you want to reduce the concentration of formaldehyde. So now the black is low level of concentration of formaldehyde, and with the black, you see at the high temperature, you already see that there are improvement. There are even improvement compared if you use the high level. So that's only good thing lah, good thing for you. So they tell you something here. If you use OFAT, you cannot see this. If you use OFAT, you will never get this interaction. You will never reach this conclusion. Okay, that's the beauty of using this multi-factor what I call analysis lah, multi-factor design to conduct your experiment. Okay, what else? So now let's see so now we know the low concentration is good. Okay, the low concentration is good thing. We get the high filtration rate. So now let's go to the next interaction. So on the left panel, on the right panel here, you see the factor tools. Okay, you can change everything here lah. You can change everything here. You cannot see. Ayah. Okay. Okay. So this is a thing. Sorry for that. So I make the full thing here. Anyway, before when I said about the all factors, here when you open is here lah. The tab on the top here. This is what I say lah. I'm sorry. I forgot to change to the full screen, but I just recap very fast. So this is the tab on the top where you can change the what we call the view. So all factors, you click all factors, you get all this thing lah. Okay. So last time I do like what? I do like this. You still can see lah, but you cannot see the top one. Okay, and then now we are in the interaction column here. So here on the factor tools on the left, you can see you can change anything lah. You can change everything lah. So here, if you see the term, we are connecting A and C. A is temperature, and C is what? C is concentration. Okay, and then let's say we want to see another important effect, which is the AD, the interaction effect, AD. Okay, so AD. So you get this graph. Okay, you get this graph. You can see here at high level. So here you can see the line here represent the stir rate. The black the low rate here, you can see the black is 15 rpm, the red is high steering rate 30 rpm. So you can see here at high temperature you can get high, what we call high result, which is here filtration around 90 something like that. If you want to know how much, you just click there lah. You just click here and it gives you the value here. You can see the value here on this next to the filtration rate, what we call the axis. So if you click outside, you get coming back lah. If you click here, you get the value there. Click outside, you nothing lah. But remember, previously we learned that low concentration is good. Okay, if you look here on this factor tool, you also have concentration here, but concentration is set at middle. Okay, set at middle. From previous information, from the temperature versus concentration interaction, we know that if you lower the concentration, you get high, what we call high filtration rate. So you use that information, bring here. So that's important. You need to use whatever you learned before, bring here. Because by default, this graph putting the concentration at the middle. Okay, at the middle. So if you try to move the concentration below, you see what happened. The graph go even higher. Even higher. Okay, so you click here, you see it's 100.6 like that. If I put in the middle here, if I go to default, it's only what? It's only 96 only. So that's why you need to bring the data from your previous interaction study. You need to use that in order to get it, because by default it put in the middle lah. So let me put here, and here they put in the middle. You can see here factor value 3. Because why they put 3? Because if I highlight this, it means the factor value represent for the concentration lah. And we know the concentration is what? Concentration is between 2 and 4. So the 3 is the middle. So if let's say I put this 2, basically you can see so like this, you can put this 3 lah. If you put 3, it go to the middle back. Tak ni. Or go to default. Yeah. But yeah, it's just the number here means that lah. Means the thing lah. So you can see the numbers change, right? From 2 to 4. Okay, from 2 low to 4. Because you know the low concentration is better, go to low. So you can see even higher lah, even higher that. And also you can switch all this thing, what we call the you can switch the axis and so on. Okay, so you can switch this thing, you can just switch the axis. If you want to use this as a y axis, you just change lah, just this right click and then change, and then you get a better view lah about what this work. Okay, so this just changing the axis lah. It's up to you how to do this. Okay, so that is the interaction plot. So you know now by increasing the by lowering the concentration, you can get even higher. Okay, so that's important part here. So on here also you have this other thing like cube plot like that. If I click there, you get this cube thing. Remember this cube thing? So this basically it shows how these 3 factors, because this is just only 3 factors here. We have the pressure in the middle here. Oh, by the way, if I go to this interaction again, let's say I go to interaction here, this one. Let's say I change the pressure. Let's say I change the pressure here. The pressure doesn't give any effect lah, because we are not including in the model. We not include the pressure in the model. That's why if you change whether go down or go up, nothing change. Okay, because it's not in the model. Okay. Anyway, let's go to cube. Okay. So for the cube here, you can see the cube. They put all what you call the combined effect. The predicted one. This all the value here. You can see all the value here is the predicted one. Is the predicted one. The value here is the predicted one. So you can see from this cube at a glance, you can see you can get high if you use a combination here. So this combination is A plus, meaning that the A is temperature, high temperature, and also high temperature, and also high stir rate, so the z-axis is stir rate, and also low concentration, because here concentration is this the axis, so low concentration. So that is the combination here lah, combination. This is different when you do scatter plot. Scatter plot is not your data. When you do this scatter plot here, okay, when you do scatter plot and when you do what we call the z-axis is filtration rate, and then y-axis is whatever temperature this thing, and then temperature this is maybe stir rate, whatever this thing. Mana? Stir rate, temperature, filtration rate, color by what is the 3D? Z-axis is filtration rate. Okay, so this thing, the 3D here is based on your data, based on your observed data, your response itself. The one that you see just now, this thing, the one that you see this thing, is the predicted one. Okay, this predicted one is different. Before you just see the data, how data distribute. This is the predicted one. So you can see here, it's looking good here, 100 like that. Okay. So that's the what we call. You can here you can just change lah whatever you want to change here. Is up to you lah, axis and so on lah. Okay, you can also use a counter plot. People like what we call the color, so they go to counter lah, so you get this thing. Okay, so you can see here this counter plot is when the concentration is bit low, because we left our concentration low before. If let's say the concentration by default is at the middle, in the middle here, concentration, but if you make the concentration low, you can see the graph change. Okay, the graph change, I mean the region change lah. So that's why you left at the where you want lah. So this counter plot is interactive in nature, meaning that you can sort of like make it bigger. So for example, you can make it bigger and so on lah. And you can if you want to get back, you go to default. But once you go to default, remember your concentration will on the middle. So you need to go back here lah if you want to see the counter that you want lah. And also you can right click, you can put a flag here. You can put flag, meaning that you know where is the prediction or how much here. So you put here add flag and so on. And you can also add another counter value, add counter. So you have another counter. So the color here, you have hot and the blue lah. So the hot one, the yellow, the warm yellow or red one here, if you look here, filtration rate is basically the color here represent the response lah. The hotter the color, the higher the response lah. So you want to get something here lah. So you see the prediction, the flag here is 50, the flag here is 70. So it's go higher and higher here lah. So to remove the flag, just right click and then remove the flag lah. Move flag, move, delete flag. Yeah, just like that, delete flag. Okay, so basically that's the idea. And also you can also do 3D if you want to go 3D. You go 3D. So it's like this. Okay, so if you go default, the concentration will go to the middle. If let's say you go low, you can see it become higher and higher. Okay, this 3D surface also interactive, meaning that you can move it. So you just click, you just move it. Okay, some people say that okay, this not look nice because they in their mindset that DOE must be like the beautiful thing, like what we call the mountain where the peak, the red in the middle and so on. That's for RSM. You cannot get it here because you do factorial. There are no curvature. Okay, so but you don't get a graph. It's no problem. It doesn't mean that this graph is wrong. You just, it depends on what you want to get. Here, the experiment, you want to sort of like find the interaction and find what it can give, whether it can give the even a higher value or not. So it's fine. So don't always think that DOE must have the graph like the mountain like that, the one that like this lah. I mean, like this. DOE, RSM. Image. It's low lah. Okay, so don't always think that DOE, when people say DOE, they must get something nice like this. This is for RSM. And even if you get something that strange like this, it's also have the what we call it also have some interpretation. So you need to interpret. So yeah, this is fine for what I call for 2 factorial. This is what you will get. You will never get this thing because this is curvature. You put the middle point, you put the middle data. But when you do factorial at 2 level, then you have 2 level, low and high. That's all. So you cannot have the curvature anyway. If you have curvature here, then something wrong. If you use a 2 level and you have curvature, something wrong lah with your thing. Anyway, so you can see if you can see from this graph, from if you lower the what we call the concentration, you get even higher the filtration rate. So you can just go, you just move this graph here and there and so on lah. You can rotate. Okay, so basically that's the graph itself. So let's say you want to optimize. So basically you know now, in order to get the what we call the best, you minimize the minimize the concentration. But the software also help you to do this optimization. If you look here on the left side, you look at the left side here, you can see the optimization part here, right? Okay, so there are 2 parts, numerical and graphical. Okay, graphical is if you want to graphical. I think I prefer the numerical part lah because it's much easier. What does it mean optimization? Meaning that the software will give you the solution for prediction lah. So if you click numerical here, okay, they will ask you, what do you want? Okay, we want our filtration rate. Filtration rate, we want what? We want high. That's what our aim. So under this optimization factor, just go to filtration rate. Our goal is maximize. Okay. When you want this, basically you want to ask the software to predict for you at what concentration, what temperature, what agitation, what what pressure that I need to put in order to get high possible value. Okay, so you maximize the filtration rate. But most people, they forget to change this thing, limit. Okay, the goal is maximization. So here the limit here is based on your what you observe before. Okay, so the lower that you get from the experiment is 43, but when you want to try maximize, why you want to put at 43? Put lah high a little bit, like maybe 80, and here maybe at 110. Maybe who knows that when the software can find the level of the factor that can give you beyond the what you get before. Because here, if you look here, the 43 and 104 is basically the maximum you get during the observation. If let's say I go to design here, okay, so you can see the maximum is 104. Okay, 104. The minimum is 43. Where is 43? This is 43. So if I go to numerical, this 43 and 104 is that, the observed data. But when you want to maximize something, if possible, you want to go beyond that data. So that's why you change the limit lah. The weight and so on is just like you just want to give some weight lah. For example, let's say you want the lower weight. So if you change this, you give more preference to the finding to the high limit. It's like that lah. We will not discuss here, but it basically give a more preference for the software to give to go to, for example, this skewed to the to the low level. I mean lower limit. So this skewed to the high limit. So this is just the weight lah. So just put default for this purpose. Just we put 1 lah. Okay. And also we want to what we call make sure. So this is our goal, maximize. But remember, our management want not only the high filtration rate but also reduce concentration. So you need to go to concentration here, and then goal to minimize. Okay, goal to minimize the concentration. So here you have lower limit and upper limit 2, 4. In this case, you don't need to change lah. Because why? Because this is the limit that it's not like prediction. This is what you use. The difference between before, filtration rate is a prediction. Maybe you get higher than 100. That's why you put maybe the range a little bit bigger. But when you go for concentration here, It's just a range. It's not like you will do like alter this range. So you just, it's okay lah. You just don't change pun. It's okay lah here. Okay, so when you do that, when you set the filtration rate high, the maximize, you see here, goal maximize, and then the concentration minimize. Once you do that, then you go to solution. So criteria, so you see the solution there. So you click solution, what you get? So you see this thing. So if you look here, this is the solution, one of the solution that the software gives to you lah. So the software said that if you want to get the filtration 100 blah 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 blah, you need to put the temperature at high level, concentration at low level, pressure at middle, and stir rate at high level. So that's what does it mean. Okay. So if you look here, pressure is 12.5 like that, right? It's not like what we call the one that we use in design. Because in design, when we do the experiment before, it's 10 to 15. But now it comes with the new thing. So this is new thing. You don't repeat whatever you do before lah. Before you already have something to do. But now it's prediction. So that's why there are some different. And this is one of the solution. If you look on the right here, the factor tools, you can also see few solution here. Solution 1 out of 38. Okay, so you can click here. So there are many solutions. So if you go to the solution number 2, it's a little bit different. Solution number 5 a little bit different. So you can see stir rate 29.4444 like that. You go solution this thing, you get something like this, change like that. But all these things, they try to improve the filtration rate. Okay, so if you go to, so we go number 1 here. Okay, so once you get this thing, once you get the thing, what you do? Okay, you know, you have the solution, meaning that you have the possible level that you can conduct in order to get the desired filtration rate. Okay, if you go to graph here, okay, what is graph? Graph is nothing lah, is not really important here. So what happened here is that what you do now is basically is to validate the model. Because now you have the software already give you a few solution. You see here, there are 38 solution. So your task now is to sort of like to show that people that your model is valid, your model is true. You need to confirm it. So you basically maybe run like 3, 4 or 5 or 6 run based on what this design asks you, and then you go to confirmation here. After you done all this thing, you go to confirmation here. Let's see confirmation. Lambat. Go to confirmation here, and you can see this thing. So this is where you can input your result after you do the second experiment. Meaning that second experiment, meaning that after you run the experiment that is predicted, that is given by the software. So let's say you run 6 experiments, 6 solution. So you put here 6 solution lah, 6 solution. 6 solution, and then it will show 6 ni lah. It will give you 6 place to put in your result. So let's say you run all the solution, solution 1, solution 2, solution 3, and so on. So let's say if I put this solution number 1. So solution number 1. So if you look here, this is a general idea lah. You lower this concentration, you high the temperature, you high the stir rate. This is basically the rough idea of solution number 1 lah. Let's say you run that solution. Let's say you run this solution and you get the value around 40 instead of 100, instead of like prediction around 100 like this. This is predicted. But let's say you get 50, and then you run the second solution. Let's say you take another solution here. You run that, and then you get, let's say, 40. And then you run again, you get like 30. And then you get 15. And then you get 37. And then you get, let's say, 80. Okay. So here, you can see at the confirmation table below, is give you the rate. Okay. Meaning that it takes the mean lah. The rate is not good lah. Meaning that it means that whatever you do doesn't confirm the predicted model. So something wrong with the model. Okay, the model said that if you do this solution, you get more or less high filtration rate. So let's say if we put like higher, let's say maybe we put 100, maybe 90, maybe 80, maybe 70, maybe this is 70, like that. Okay, so here still red, meaning that is a little bit far from what they want. So maybe if let's say I put here 90, because it need to reach 95. Let's say I go this 100, 90, because it not reach the, let's say I go 100. Oh, because they are 7 run, so I need to, that's why they go low. So let me, if I put here 90, then it's okay lah. Not okay also. Oh, because now it's 8. Salah lah ni. 6, let me put 6 again. Okay, so you can see here 6 run. This should not be red here. It should not be normally should not be because I put this run number 1. Oh, that's why this is run. You cannot put here lah. You cannot distinct, because this they try to go for this depending on this. But anyway, the idea is this. The idea is that you run your what I call your whatever software predicted to you. You put the input here, and then it give you all this thing lah. All this thing. Okay, all this value here. So I don't know why this is red. Actually, it should be black here. Okay. Maybe something wrong here. Anyway, so that's the idea. So you run at least probably you can run around like 6 like that to validate your model. The idea for you to do confirmation is for you to what we call to confirm your model. If your model is sound, then you will get what the model predicted for you. So that's the idea. So once you get whatever the model tell you, then you get what you want lah. You confirm the model, and also in this case, in our case here, let's say here, in our case here, we already satisfy whatever this what we call the management want. They want to increase the filtration rate, and we see that in order to increase the filtration rate, we found that reducing the formaldehyde concentration is possible. So that is basically the purpose of doing this 2 factorial design. In this case, we want to characterize, we want to see whether the what we call the filtration rate, if you reduce it, can you increase the formaldehyde concentration? If you reduce that, can it be improved? Can you improve the filtration rate? Then you found it's yes, then it's good lah. And then you run the confirmation and so on, then everybody happy.